All right. So one of the key things with pressure systems, and I don't have the colored markers to really go along with it, um, but one of the first things to know about pressure systems is that they're defined by how the pressure is changing, and it's all relative. So air pressure is the measure of the weight of the air above you. So on the surface here, the pressure's higher because there's more atmosphere or air above us. As you go up a mountain or go up an elevation, you're getting higher up in the atmosphere. There's less air pushing down on you. So that means you'd have a lower pressure automatically by default. If you were to go down like into like the Grand Canyon or something like that, your pressure would go up because there's more air or atmosphere above you. Now, as far as weather systems go, the way you can tell the difference between high pressure and low pressure is you can look at a couple of things, but one of the key things is that as I go towards the middle, and typically the pressure goes by fours, my pressure gets lower. So as I go outward from a low pressure system away from it, in any direction really, horizontally, vertically, whatever, my pressure is going to go up, right? So pressure increases as I move away from the center of the low, right? The opposite would be true for high pressure. So the only difference, like how you distinguish them, I mean, there's a lot of other differences, is that on a map, these are isobars, lines of equal pressure, is that as I go towards the center, the pressure would go up. So that means if I move outwards from the high in any direction, my pressure would go down. All right, so that's a visualization. Then that would basically answer number one for you on the form. All right, so now we're going to focus in a little bit more on the low pressure side of things, because high pressure is happy weather. It's stable, it's settled. Like today, for example, it's sunny, there's not a lot of clouds, the air is sinking. Fronts don't ever go with high pressure. Fronts never go with high pressure just because it's stable weather. The sinking air doesn't support the unstable weather you need to create like clouds and precip and things like that. So this will tie into a few of the questions on the forms. Again, I'm going through the forms and I'm just I have it in the background so I can see the concepts. So I'm basically just covering what you need to know to answer those questions. All right, so direction of wind around a low. So we have a low pressure system, all right? Typically you're gonna have a warm front here. Okay, so that means like your temperatures would be warmer in this area. So I'm gonna make up a number and we'll say like this is 68 degrees Fahrenheit. And then you have a cold front. And then behind it, your temperature is going to be cold. And then ahead of it, it tends to be cooler, but not as cold. Okay. So what these systems generally move towards the northeast. So it's going to be moving like in that direction towards the 54. So the temperature would go up where the 54 is now, it would go up. And then the temperature at 68 would drop actually when the cold front goes past it. All right, so a couple of things here. The winds go counterclockwise around a low pressure system. It's a huge concept. It comes up a lot. It'll definitely be on that test I'm going to give in a couple of weeks. Counterclockwise towards the middle. So the winds behind the cold front are generally from the west or northwest. Okay, and that's one of the reasons why it's colder. If you think of what's like west and northwest of here, it's like Montana and Canada. So the colder air gets drawn in from those locations. In this part, this is known as the warm sector where the 68 is. That's going to be a southerly wind usually, so south wind. So it's coming up from the south. South of here is like Florida, warmer in Florida, so it brings warmer air in. All right, and then ahead of the front, these tend to be easterlies. East or northeast. All right, and that's going to bring water. So it's bringing in the temperatures coming off the water, the Atlantic, in our case, which helps to sort of moderate our temperatures. So the winds are backing off the ocean. The ocean tends to be cooler in the summer and warmer in the winter than the ground, just because it heats and cools slower than the land does. So when the winds are off the ocean, it tends to have sort of like a moderating effect on the temperature. So it'll be cool here, cold behind the cold front, and warm inside the warm sector. So the warm front's already gone through here. So the warm front went through, and now the cold front will eventually go through. So what you can expect is right now, like here, at the 54, if this was a station model, that's a big 54 for the station model, but it would be cloudy, and precipitation tends to happen ahead of a warm front. What happens is the clouds will fill in. You'll get those high, thin, cirrus, wispy clouds that you can sort of see through. They look really cool in the sky if you noticed. And what will happen is those will start to increase and thicken, meaning like the sun gets blocked out and they get darker. And then eventually you get the rainfall. Remember that a warm front looks like a ramp. So like the warm air gets lifted up over the cold air. So the clouds work their way in from the top down. That's why typically you'll see a halo around the sun or the moon ahead of a system, because the upper air, the troposphere and the lower part of the atmosphere starts to fill in with moisture, and it creates a halo effect around the sun and the moon. So the winds here would be out of the north or east to northeast. I'm just going to draw an east wind at 10 knots, right? Now inside here, it'll be nice and toasty. It tends to be more humid too, but it's going to be more fair conditions. Winds are going to be out of the south, maybe at 5 knots, right? Half flag in the middle there would be 5. So it's gonna be warm in there, and there's gonna be a brief like break in the precip in the clouds. But then at the cold front, like right at this line is where the action happens. It's much stronger, it has a much bigger lift than a cold front or warm front. It's like a ramp. So it's gonna force the air up more aggressively. So rain's gonna happen right at the front. Tends to be heavier and faster than the warm front precipitation. And then behind it, it's going to be clear too. So you might get thunderstorms right on this, near this line, but then behind it, it's going to be clear and colder. So it's colder, drier, and more stable, maybe a little bit more breezy too, because typically you have your high pressure moving in. So this will answer this question 2 with like the wind direction, question 3 with where it's warmer, where it's colder, and where it's in the middle, sort of. Let me just check this one. I need to just scoot this to the side. So the 4th question was asking about like what would happen in South Carolina after the front goes through. So in that case, like if we're saying like South Carolina is coming this here, the cold front they mean. So after the cold front goes through, what would you expect behind the cold front? So sort of what I was talking about with this one, with the temperature change. Number 5 talks about what happens with a cold front. So let me just quickly run that one down. So typically, there are 4 types of fronts, but really for our purposes, like we generally deal the most with cold fronts and warm fronts. Stationary fronts happen on occasion, and those ones are really annoying because it's cloudy and rainy for a long period of time. And then occluded fronts are very, very brief, and it's just sort of usually bigger part of a bigger system. So it's really like not a huge impact as far as what we see weather-wise. It's already part of something happening. So what we see on a more regular basis, like more like every few days or weekly, is going to be warm fronts and cold fronts. So some things to know about cold fronts, and I'm just going to scoot this over here. What happened to my square? There we go. All right. Just make sure that's up. All right. So with a cold front, a couple of things to note about that. So heavy, short precip at the front. Right, so right as that front swings through, you'll see the heavier precip, but for a short duration. So it doesn't stick around usually for too long. You'll have pressure will drop, then increase. All right, and sometimes the pressure drop can be quite significant. If it's like a severe thunderstorm or a really strong cold front, it can drop really quickly. That's when I tend to get my headaches and aches and stuff like that. And then behind the front, the pressure will go back up, and that's going to lead to the improving conditions. Winds south ahead of the front, north, northwest behind the front. All right, so you have a big wind shift there. Sometimes these fronts don't have a lot of moisture with them, so you won't even like notice, like it might just cloud up a little bit, but there might not be rain or thunderstorms or snow. It could just be a wind shift that tells that a front went through, and it'll bring in cooler, drier air behind it. and you tend to have like clear skies, then clouds, heavy precip, then clears again. And then with the temp, high to start, low after. Okay, so ahead of the cold front, it's going to be warmer. Then the cold front comes through and it brings in colder air, so the pressure will drop. So that will give you your answer for number 5. It says, which of the following does not happen with a cold front? So you can use that to help answer that question. So we already talked about number 6, but just as a quick overview for both of those, if we're looking at a low pressure system, low pressure, lousy weather. The reason why it's lousy is because it's taking all these air masses from all over the place and mixing them in the middle. So counterclockwise towards the middle, right? So you tend to have like, this would be like a maritime tropical air mass down here. This would be a continental polar up here. This tends to be like maritime polar. So it's cooler, but like wetter ahead of it. This is warm and wet, and this is cooler and drier. So you have all these air masses mixing in the middle, and that's what creates the storm. With the high pressure, it's going to go clockwise and out. Okay, so it goes along with the clock. So sometimes people like to draw the clock in there just to remember clockwise and outward. All right. And now the other thing to note is pressure always goes to high to low. So this high pressure would actually be a part of this low pressure, like they wrap into each other. It's sort of like a figure 8 when they put it together. Okay, so that answers the questions for 6 and 7. And then the final question is actually from this week. And this is for North Carolina. And so with the forecast, it talks about how, let me actually shift this over just a little bit so I can see it. So it talks about, this was for Wednesday and today for the Carolinas. So the front already went through there, but let me see. Okay, so this is for Wilmington, North Carolina. It was from this week when I made this plan. It was from that time period. So it was mostly cloudy on Tuesday night with a low around 63. Winds were out of the southeast at 5 to 7 miles per hour. Okay, so it was pretty warm, even though it was South Carolina or North Carolina. That's still warm, 63 at night in May. And then the winds were out of the southeast. Then for Wednesday, it was a chance of showers and thunderstorms. Then a chance of showers, mostly cloudy, but then clearing out. High of 77. Winds out of the west, pretty breezy as well. Now, we'll notice the difference now going into Wednesday night and Thursday. So Wednesday night, mostly cloudy and then clearing, low of 48. So Tuesday night, the low is 63. Wednesday night, the low is 48. So that's a big drop. It's not always that significant when a cold front comes through. But to see a drop like that, that's like about 15 degrees or so, that's a big drop. And then if you'll notice, the winds are also out of the northwest, indicating a cold front. And then on Thursday, today, high pressure's moved in, it's sunny, and winds are out of the northwest. But if you compare, the Wednesday high was 77 and the high today is going to be 68, that's an 11-degree difference. So that's quite, or a 9-degree difference. So that's quite the drop there as well. So it got colder. The winds went from like a south direction to more northwest direction, and then it cleared out behind it. So that's a low pressure system with a cold front, right? Because of the wind shifts there. Remember, high pressure doesn't have fronts. So it's just clear and stable. And so since we have precip and clouds and wind shifts here, we know it has to be some kind of low pressure system. And the fact that cold air is replacing warm air is what tells me that it is a cold front. So that's all of your answers. That's a quick one. So if you haven't done this one already, it's nice and quick. If you have done it already and submitted it, I can't let you go back and correct it. Unfortunately, the system won't let me. But again, I'm going to test on the same stuff next week or the week after for your test. So it should be a nice, easy review. So I am going to open it up. If you have any questions, you're welcome to stay on.